All right, so today what we're going to do is we're starting to look at seasonal indices. So what we have been doing before that is obviously we've been looking at time series. So we had where we have a time along the x-axis, and then we had something that some response variable we've been looking at. And so we had, say, time series, and we talked about like trends and things that are happening. And then we looked at doing a few smoothing techniques. So we had the mean and the median smoothing. So what we do when we're smoothing is we're often taking away those extremes. So we know that those things are happening, but we're trying to get it to be a bit more smooth and see what the overall trend is. What seasonal indices is when we have data that has a seasonal trend to it. So remember, seasonal trend means something's occurring like the same time every period. So say if we had what this scenario is that we go through in the notes is that they're talking about jumper sales over the 4 seasons of the year. And so if you think about it, we're probably going to have a peak in, say, winter. You know, it would peak up in winter and maybe be a bit less or something in summer or whatever. We'll soon see. Okay, so what seasonal indices are is it's a smoothing technique to sort of take away that. Like, we understand that there's going to be more in a certain time of the year, but we want to see what overall is happening. So when we use these seasonal index, so a seasonal index, it shows how a season compares to average. So if you have a seasonal index of 1, that means you are average. So if you have a seasonal index of 1.2, you are 20% above average. And if you had a seasonal index of, say, 0.9, that means you are 10% below. Oops, sorry. Below, it doesn't let me, below average. I'll just say, you can write that in. All right, so what happens as well, so when we use the data and we calculate these seasonal index. So this way we calculate a seasonal index is we take the value for the season. So say they were talking about jumper sales and how many was sold in summer, and they told us a certain amount, that would be the actual. And then they will divide it, if we divide by the seasonal average. So that means we added up all the sales we had for summer, autumn, winter and spring, and we divide it by 4 to get the season average. So that's how we calculate a seasonal index. So that's what they've done. So here they've done that, and they've given us the seasonal index for these, what happened with these jumper sales. So you can see here that summer is actually 3% above average because it's 1.03 average. And autumn is 15% above. And we're going to change this one to 1.13. I think it was wrong. So it's 13. Oh, we'll just leave it. Doesn't matter. This one, at this point, it says 30, so it's 30% above. Now, what happens is this one here is missing, so we don't know. Well, when you add up all the seasonal indices, you should get the number of seasons you have. So here, because we have 4 seasons, so the seasonal index will add up to 4. Okay, so if we were trying to work out what was missing, so if we make that 3.0, if you add them all up, they should add up to 4. So what they've done here to calculate what spring was, they've said 4, you can either say 4 minus all the other ones added up, and that ends up how we get 0.52 in spring. So no one's buying like it's a below average. So the sales are dropping off in springtime. Okay, so that's the answer, and that's how they found that. That can be one way of finding a seasonal index if you don't have all the data. Sometimes if we have all the data, we would just have to calculate it using this formula up here. Okay, so now because spring is 0.52, it is actually 48% below average, because if you do 1 minus 0.52, you get 0.48, and that's why they're saying, you say spring is 48% below the average. Okay, so it's how far you are away from 1. If you're above 1, you're above average. If you're below, how far below 1 are you, is how below you are. So what we're going to do with these seasonal index is we're going to use them so we know how far above or below average they are. So what we're going to do is we use them to what we call deseasonalize the data. So it's like a smoothing technique. So what we're trying to do is bring them back to average. And so we deseasonalize. So here's the formula that you'll need to know for deseasonalizing the data. So what you would do is you take what actually happened and you divide it by that season's seasonal index. So if you have a look, if they said here, so we'll do this example. It said the actual sales for winter were 2,500. Find the deseasonalized figure. So deseasonalized, looking up at that top formula. So deseasonalized is you do the actual divided by the seasonal index. So if you think they told me we actually sold 2,500, but if you we look up here, the seasonal index for winter is 1.3. So tell me, is winter above average or below? Above. So if I'm trying to smooth off and deseasonalize the data, do you think is the actual sales number going to go down or go up if you're trying to bring it to average? It's going to go down, isn't it? So when you do 2,000 divided by 500 divided by the seasonal index, you end up with that number, I'm just going to round to a whole number, is 923. So it's brought it down, it's deseasonalized. So that's the deseasonalized value for that data. Now, if you look here, they do another one. In this one, they want you to find the actual sales, but they told you what the deseasonalized figure was. So I'm just going to write how I would do it. So say deseasonalized equals actual over seasonal index. So you know the deseasonalized number is 1,200. The actual is what you want to know. So I'm just calling it X. And the seasonal index they would have given me, so summer up here, 1.03. So what we're going to do is we're going to just pop in our calculator. We can just go solve, comma X, and you'll get X equals the 1236. Don't worry about rearranging the formula. Always just keep using the same one. And if there's one bit will be unknown, and just use the solve function. So if you think about it, if the deseasonalized figure was 1,200 and you look at summer and summer was above average, so when we deseasonalized it would have dropped, and that's why we see this number a little bit higher when we go back to the original. All right, and are the figures for summer higher or lower than average, and by how much? So this question was just put there. I mainly did it too, was because the 0.03, don't write 30%, it's actually 3%, all right? So just be careful of that, it's 3% above. All right, so that's deseasonalizing, and that's just doing one like individual figures, but what we like to do, and we'll see in a minute, is we like to deseasonalize the whole set of data, and we'll do that a bit later on. But let's go through some of these exam questions, and they're going to help you with this stuff. Okay, so use the following information for all these questions, and the table below shows the long-term average of the number of meals served each day at a restaurant. Also shown is the daily seasonal index from Monday through to Friday. So you should be noting here, this actually has 7 seasons because we're doing 7 days of the week. Okay, so this one has 7 seasons. So we're seeing patterns happening on the 7 days of the week. Okay, so if we look at the first question, it says the seasonal index for Wednesday is 0.84. This tells us, so they're pretty much asking you to explain what a seasonal index of 0.84. Well, we know that's when if you go 1 minus 0.84, it equals 16 or 0.16. So therefore, it's 16% below average. So which question says that? Answer, I should say. It's A, yeah? So that one's pretty easy. The next one, this next question, it says the seasonal index for Saturday. So that's up here, but Saturday is missing. Now, before we saw if we added all these up, we would get, they should equal 7. We can't do that when there's 2 missing, can we? No, it's impossible to know. We're only going to know what the 2 of them combined are. We wouldn't be able to tell what each one was. So that means we're going to have to just do it how you normally calculate a seasonal index. So they want seasonal index. So what you should first do, just write the formula, and then things might come to you. So seasonal index is actual over seasonal average. So if you look at it, the actual is up here. This is what actually happened. So that's 190. And then we're going to divide by the season average. So the season average is when you add all these up. You add them all up and you would divide by how many? And divide by 7. So okay, so if you add them all up, it ended up being 919, and then if I divide by 7, so I ended up with 131.29, okay? That was my seasonal average. So if I put that under here, the season average, so 1.13.29, whatever, we're going to end up with a 1.45. So that's how I get that answer. So that's how you could do that one. And then if we wanted to find Sunday, we could do it as well. But they just asked for Saturday. Okay, now let's just do this last question here. It says last Tuesday, 108 meals were served. So they're giving you an actual there. Now it says the deseasonalized number for Tuesday. So just write, all right, deseasonalized, I'll write the formula, is actual over seasonal index. So the actual they gave me. And what's the seasonal index for Tuesday? They said up here that it all relates to this, so I can go and read it off. And what is it? 0.71, so I'm grabbing it from there. And then we get the answer, I think it rounds to 152. Okay, these exam questions, it's nearly on every exam, and I'm not sure why it's always poorly done, but it's not by our school, I can tell you that, because we've got them all here and they're exactly the same, so you can just follow this. So here it says a retail fashion sales for a large department store in spring has a seasonal index of 1.25. Now, to allow for the effects of seasonality, when you see that wording, that is just another way of saying deseasonalizing, yeah? So just write that. That means deseasonalizing. So they're saying what happens when you deseasonalize the values of these sales. What are you doing? Are you increasing or decreasing? So we're going to have a look. So if you have a look at the deseasonalized formula, so if you go to deseasonalize something, it's the actual divided by the seasonal index. Okay? So I'm going to show you just to see what would happen so you can see how the data would change. I'm going to do a made up actual. So I'm making this up of 100. And the reason I'm using 100 is because they want to talk in percentages. So if I see how the number 100 changes, I can quickly just quote how it's changed in percentage, can't I? So if I put that into my formula here, if I go 100 divided by the seasonal index, which we've got here, yeah? So if I do 100 divided by 1.25, what I actually get, the answer is I get 80. So if you think about it, my actual was here, and then once I deseasonalized it, it went to 80. So what happened in here? What did it drop by? Yeah, it was dropped, it was minus 20%. So it decreased by 20%. The other thing you should do when you're doing these questions is have a little think about it before you start as well. If the seasonal index was 1.25, it's above average, isn't it? So it's above average. So if we're deseasonalizing, we definitely are dropping the number. So you should at least get rid of those, okay? And sometimes that can help, because it'll reduce your, you're down to a 50-50, and you're looking at it in a different way, and you might spot a mistake. Let's do this next one. So I'll show you with the next one how we'll just do the same. So it says the seasonal index for summer is 0.8. To correct for seasonality, so remember when you see correct for seasonality means deseasonalize. And so when you write, all right, deseasonalize, and you know that means actual over 100. Oh, sorry, over seasonal index, sorry. Yeah. So here they want to know what's actually happening when you do deseasonalize it. So if I use my made up 100 and I divide it by their seasonal index they gave me, I end up with 125. So I've gone from 100 up to 125. So what have I done? I've increased, which makes sense because this was below average. I've increased by how much? 25%. Okay? So once again, you could think about it. If summer was below average, then when you're deseasonalizing, you should be increasing it. So you could get rid of those three. So you can see they say correct for seasonality. So we know that means deseasonalize. Okay, so we've gone, I've used this is my made up 100. Oops. And I've done that. And so now I've gone from 100 down to 62.5. So what's that? It's dropped by 37.5, hasn't it? Yeah? So it's reduced by 37.5. Yeah, Jacob? No. Okay, so you can see that we've done how many questions? That was nearly 3 questions. That's from every year, or after. So every year. So we've nearly got a guarantee we're going to have something like this in there. All right. Okay, so is everyone think? I am just making up the 100 because it makes the percentages easier, okay? Also, just quickly before we go on, can you see, this is what you should do. Sometimes you might not know what to do. And that's pretty normal. But can you see, if you write, all right, it's deseasonalizing, I've got to do something, it's something to do with deseasonalizing. So if you write the formula out that you know for that, sometimes things come to terms, it'll come, you work out, oh yeah, because you'll go, I've got the seasonal index. Sorry, that should be seasonal index. So you might say, I've got the seasonal index, and they want me to find the deseasonalized, so I must have to do something, and then you'll remember what you need to do and things like that. That's what you should do if you don't understand, or if you don't know what you're doing. All right, let's go. Sorry to start on this bit. Okay, so what we saw before, how we calculated a seasonal index when we had the Monday to Friday. So we only had 1 week, or one section of 1 week. So what happens here, we're going to show you what they do, say, when they have multiple periods. So here you can see we've got 3 years of data, okay? And it's got the 4 seasons, it's seasonality. So we need to find the seasonal index for this whole data. So the way you do it is you find the seasonal index for each quarter for every year, and then you average that out. So let's have a look what we do. So this in the yellow, these yellow numbers are the actual numbers. So this is actually what they sold in the shop for those 4 seasons. So when I try to find the average for that year, what I do is I've added them up and I've divided by 4 and I got this number. That's the yearly average. Okay, so they've done that for every year. So they've added them up and they're divided by 4 and they get that yearly average. Now we do that because we are going to find the seasonal index for every season for every year. So see this summer? So this is the seasonal, these are all the seasonal index for every season. So I'll do up here. So seasonal index, the way we normally find it is we go actual divided by seasonal average. So this number down there, the actual for summer in the year 1 was 920 and the yearly average for that year was 923, and that's how they ended up with that number 0.9967. So that was the seasonal index for summer of that, the first year. If I do another one, say I do I'll do winter. Okay, so say I do seasonal index for, I'm going to do winter year 3. So the way I've done it, it's going the formula, actual over seasonal average. So the actual for winter year 3 is there, so it's 1450. Now I divide it by year 3's seasonal average, which was 1183, and that's how we've ended up with 12257. Okay, so that's how they've found all these individual seasonal index. Now, how we got the overall seasonal index, so like we can say, all right, the seasonal index for all of this data is they've added the 3 summers up and then divided by 3, and then they got this answer down there. Yeah, so if I was doing winters overall, this is the overall, you might write, the overall seasonal index, I would have added these up and divided by 3 to get this answer. Okay, so that's how we've calculated an average. Now, you often get asked to do this on a test, but I've now seen it coming up in the exam. So we need to be, and I'll show you those exam questions later. What happens now, this table here is all the deseasonalized values. So these are all the so what they did is because we know deseasonalized is actual over seasonal index. So say for this one, they've taken to deseasonalize it, they took what actually happened in summer. So if you look back on that first table with the yellow numbers, summer in year, so because this is year 1, year 2, year 3, what actually happened in summer year 1 was 920, and then we used our overall seasonal index for summer, which was 1.03. Okay, so this was, and then we ended up, and that's how they end up with this number there. So we end up with 893.20. Okay, so they've deseasonalized every one of the sales using that overall seasonal index that we calculated at the end of that page. Then what happens, so once we've got all the deseasonalized values, that's what we want to now graph. We don't want to have the original sales with the seasonality. We want to graph the deseasonalized values. So into your calculator over here, you can see I've put the seasons, or you might want to call them the quarters, because there's 4 of them. And then you put your deseasonalized values in another list. And then obviously deseasonalized values will go along here on our scatter plot, and what quarter it is along here, and we'll get this new time series which isn't as jagged. Okay, so what we need to be careful with is this is in the first year, this is quarter 1, quarter 2, quarter 3, quarter 4. In year 2, this becomes quarter 5, yeah? And this would be 6, 7, 8. And then in year 3, quarter 9, quarter 10, quarter 11, quarter 12. So we have to be careful with what quarter so that we list it in right. So once we've got these lists of values as well, what they like to do now they've smoothed it off, now they want to get that linear regression line. So in this data, we're going to do that, like what we've been doing, the lin reg, the A plus BX, yeah? So your X list will be your quarter number, and your Y list is going to be your deseasonalized values. Okay, so they do that, we pop that in, and we get an equation. We get an equation to predict the deseasonalized value. And here they've done that here. So looking at all these things that are exactly the same. So this is our A value there, the y-intercept, and this is our B value there, the slope. Okay, all of that's still the same. And then what they'll do, they've now created this equation, or they might zip you all the way up to this equation and say this is the equation, and then they might get us to do some predicting, and that's what we're going to do on the next page. Seasonal index, so we are now going to get us, so here's our deseasonalized formula that they've used. So they've done all that data, they've deseasonalized it. Remember, this is our A, this is our B value. Okay, and now they're telling me quarter 1 is summer 2008. So if you think 2008, and we had summer, autumn, winter, spring. Okay, so summer's quarter 1, 2, 3, 4. And then obviously if you went on to 2009, summer would be 5, 6, and 7, and 8, and so on. So here it says, what is the actual number of jumper sales for spring 2008 found to if the seasonal index is 0.52. So they've given us this formula, and then they've given us the seasonal index, and the question is the actual. So how do we tie it all together? Well, we know our original deseasonalized formula is actual over seasonal index, okay? So if this is my question here, there must be a way to get this and this, and there is. We're going to use the formula to get the deseasonalized value. So what I'm going to do is I'm writing the formula. Now, I have to times it by the quarter. Now they want for spring 08. So what quarter is spring 08? It's quarter 4, yes? So I'm going to times this by 4. So that's the deseasonalized value equals actual, I don't know, over the seasonal index they gave me 0.52. So what you can do in your calculator is you can actually pop in solve and comma X and just do it like that. So we just do this every time, whichever one we don't know, we can just pop it in like that. Now, I want you to do this on your calculator and make sure you get the answer I get, because it's fiddly and you might be doing it wrong on your calc, and I want to make sure you don't. Okay, so we get 503. So here, with the next one, they're asking the same thing, the actual, but they want for autumn. So autumn 2009, what quarter is that? That is quarter 6. So I've listed them up there anyway. So off we go. We would do the same, except we would put 6 into our formula here, okay, and then equals actual we're trying to find out, and we've got a new seasonal index. They're saying use seasonal for autumn, which is 1.5. So I can pop that into our calc, just use the solve again, comma x, and we end up with an answer of 181,185, okay? And then the last one, we just popped it in there. What quarter is winter 2010? So we'd be getting into the third year here, and be 9, 10, 11, good. So it'd be quarter 11. So into our formula for deseasonalized, we have to put quarter 11 equals x, and this one's seasonal index they've told me is 1.3. So then we just solve, comma x, sorry, it should be brackets in there. And then we end up with an answer of the sales would be 1548. Okay? Alright, so on an exam or that, you might just be taken straight to this point, and that's what you do. But how we got that deseasonalized value equation, we just did it the page before, okay?